Alrighty, welcome everybody to my talk. I'm Peter, and I will be talking about self-building Gopher today. Before I start, AI told me to ask a couple of questions, so you guys tired as me? Or all okay? Nobody tired? Right. I just flew in from San Francisco yesterday, so I'm a bit jet lagged still, but I will try to make it a good experience for you guys, this presentation. So the self-building Gopher, what is it and why are we talking about this? First, I will start with something a bit different. If you look into my summary of the talk, I was trying to look into how to use Claude Code, and we use Claude Code for many of our agents. But for the past month, it hasn't been really nice. And 2 days ago, Anthropic actually came and said, oh, hey, we had a bunch of bugs for the past month in Claude Code. In the meantime, I made a change, so everything in this presentation is in Jenkit. So Google technology plus Gemini, also Google technology. But whatever you see here, you can literally use any kind of frontier LLM, any kind of framework that you want. We will just be using this one, but just let AI read through documentation of anything and just use whatever you want in this. So you can use Tomash's ADK as well. It's very close to this one. And the second one is, anybody remember small agents? Anybody work with them? A year ago, it was a really big thing. Small agents, anybody? Yeah? Nobody, really? Can you raise your hand for small agents? Oh my God, all right. So this will be a totally new thing for everybody here. So a year ago, there was a framework called Small Agents, and everything it did was in Python. So whatever question you asked, you could have asked hello, and it wrote a Python script and executed it and said hello. And you asked what is 2 plus 2, and it went and wrote a Python script and said 4, and so on and so forth. And it was a year ago, but I don't know, 6 months after that or so, actually Cloudflare came with this blog post saying, there is a better way to use MCPs, because MCPs or tool calls, they are just JSON in, JSON out. And it turns out that in the time, agents started to code better and better. And so it was worse to call MCPs and JSON tool calls. It was far better for them to just let them code. So you can just leave them with library references. And what happens is you leave them and they write the code that they execute afterwards. And this whole presentation is about such agents. So we're not going to let LLMs, do counting and do math. What we're going to do is we're going to let them write every code that you're going to see here. And this was, I think, well, what is it, 7 months ago or so? We've been using these agents for more than a year now. So I think there's quite a lot, that changed. But the same thing is still true. Whatever you can code, you can audit, you can test. And this is what we're going to do today. So let's start. Anybody here in the past couple of months heard the question of, can you make an agent for me for this? Hands up? Yeah, awesome. So many executives are currently coming to everybody in the team and is like, can we have an agent for this? Like, can we automate this stuff? It would be so cool. And then it's like, okay, so can you show me like what I need to automate? Oh, it's this one button. If you click it and then you click this one button, it's like, okay, awesome. Like, you need an agent for this? Great. But there is also other stuff, which is like, oh, we need access to this database. Like, anybody tried giving like salespeople access to their production database so they can pull some data? Awesome idea, right? You don't want to really do that. And even if they try to use like ChatGPT, they're gonna be like, tell me how many customers do we have? First answer, 100. Second answer, 20. Third answer, 20,000. It's like, so how many customers do we actually have? Well, it depends, I'm an LLM, so I just make stuff up. And we want to currently avoid this as much as possible. So, I added this, like, if we only had an agent for this, because I heard this all the time when I'm talking to people. And there's one thing, which is building agents. That's easy. You can build anything right now. You can vibe code agents. You can even let the salespeople vibe code things. You shouldn't, but you can. But there is this one thing, which is maintenance. What do you do afterwards, right? Like, you make an agent, and then just like, so I made the agent for you for these 1 or 2 use cases that you asked for. 2 days after, they're at your desk again. Can you please add this tab? I needed to click also this button, not only these two. And 2 days after, they're like, I needed to query something, fetch something. And suddenly you're a support guy for an agent that does something because you're just vibe coding it, of course. And so you're kind of a proxy between the sales guy or the marketing guy and the code. And also, this is not something that's really helpful. It's not really something meaningful for me, for example, to be a proxy. So we started building these self-building agents. And what it means is they write a code that you can improve. There's a set of use cases that you can execute. And if the agent already knows about the use case, it goes and executes it. If it doesn't, it goes to you and asks for approval, and then executes it again. So on the right side, what you can see is such a session, and we will basically go through all of this on this session. So I will start with high-level architecture. And the architecture for this setup is very simple. As I said, you can really use any kind of technology. You don't even need to use Go, right? You can use whatever you want. It's just that Go is incredibly easy language. It's statically typed. It's checked via compiler. There's so many things that you can do just very, very easy. That when you try to execute this bot in JavaScript or Python, you're gonna end up just with many different errors that never end, that are never there in Go, just because of how the language works. So you will have two databases. The first one is for the bot, where you have your sessions, all your user data, stuff like this. The second one is for the business data. Currently, what we have in this talk is a data agent. So it will connect to a database. It will start fetching from there. But when it comes to any kind of agents that you want to build, you can literally build anything here. So you can replace that business database with SDKs, with telemetry, with other AI LLMs, with other agents, with other MCPs, whatever you really want. It works with anything because in the end, it's just a piece of code. And then we have a library. And this is the core part. This is what I will be talking about throughout the whole talk, which is the code that is written by agents for agents to execute. So we have two databases. We have bot runtime that is separate. We have main Go, which is basically a program that the bot writes, and it uses all the library that we give it, and then it executes and returns the value. It's pretty easy, right? The concept. Now, we have this part, which is for requests where search didn't match. Then we have a separate agent, which is more robust, and it goes and tries to build the stuff for the person. So if we have, I don't know, a database of customers, and it knows how to fetch customers, but it doesn't know how to do this certain aggregation of how many customers did we get or did we onboard every week in a year, right? And it doesn't have this. It's gonna go and it's gonna build this and let you approve whether it makes sense. So let's go to the library. Now, hopefully everybody can read AI-generated code. Because I think this one is pretty easy. So let's just go through it real quick. Connectors is the first layer. And it's a layer where you say, do whatever you want with this. I gave you authentication to everything that you can do. So you want this layer to be authenticated really only to things that you want the bot to do, right? Because it's the total raw layer of it can do anything here. But this is the layer where it can't change anything. So you just tell it, just go and execute whatever you want in the database. But at the same time, you can't do anything else. You can just use this one function called exec. And you can do this for databases, which is what you see here. You can do this for cloud, for services. You can just connect Google SDK or whatever AWS SDK here and just let it do whatever you want, expose the function as they are. You can talk to other LLM agents, or you can post things to Slack, Discord, whatever, right? So this is the layer of do whatever you want. And what we want to make sure here is that you only give it a read-only access, for example, to the database, so it doesn't write stuff, right? But then we have the second layer, which is far more important than this. This is kind of really just a way for the LLM to understand what it can do and what it can't do. But then we have a layer called building blocks. And this is a layer where for each building block, in this case, we have a single database, a single database table. So for an example, this one is for orders, so it can query orders. And then we have one struct that goes in and one string that goes out. And there is a particular reason why it's handled like this, because you can do many things in many different ways in Go, but there's a certain good pattern or good blueprint when we were trying to discover what is the best way to actually talk to LLMs this way. This is what we found out. And why this works, it's hard to say, but the whole idea behind it is that because we are fine-tuning so much on JSON objects and JSON in, JSON out, the Go structs are currently almost the same pattern matching, right? So if we give it like one structure that has multiple structures in it and so on and so forth, and just let it fill in the structure, they know very well how to fill in the structure. So the whole idea here was one structure in with multiple substructures, one string out, which is going to be the query that we're going to execute in the database. So when you look into this, you can see query orders, and then you have multiple order options like dimensions, aggregations, filters, and so on and so forth. And of course, this is not complete. And you might ask, why can't we just let the LLM think in SQL? Anybody try this? Anybody try text to SQL already? Text to SQL, anybody? Yeah? How does it work at scale? It doesn't, right? It doesn't work at scale. And so this is the thing, right? If you let the LLM do whatever they want, even 90% it can work. But the 10% is literally where your team will hate you, especially for people like marketing and sales, because they can't tell the difference. They can't tell if the data that you're giving them is right or not. And it takes like one or two of these events where the data is wrong for everybody to start doubting whether the agent is actually doing the stuff that they want it to do. And so what we do here is we just limit the unlimited number of possibilities that SQL has into use cases that actually make sense. Because of course, you can query orders and you can just make a SQL to, I don't know, join with itself multiple times and then subtract across different fields and whatever. And you can say, yeah, like this would be possible if I gave it to the agent. But is that a real use case? And we're finding out there's not that many use cases. Even if you look into large tables, there's a very limited number of use cases that people actually want to execute over and over and over. So we give it an ability to do many things, but we still see that even this number of use cases already covers a very large part of what users actually want to do, even if they can do in SQL whatever they want. These are the things that it actually execute. So that's the first part. And then the second part is how it looks like when you open it. And yeah, I wouldn't really want to read this code all day, to be honest. But what is really good at it is that it's auditable because you can actually see it, even though it's generated, right? LLM generated this. You can actually see it. You can see what it does. In this case, it's just a bunch of ifs. But the second thing is it's fully testable. So what I mean by this is that if anybody comes back to you and says, hey, this function in this use case doesn't really work well, just write a unit test for it. It's not that much hassle. You don't need LLM and try to debug prompt and be like important, just don't hallucinate, don't do things that nobody asks you for, don't add comments that nobody asks for. You don't need to do that. You just go and you write a unit test for it. And then you let the LLM correct itself or something. Or you can correct it, but who would do it nowadays? And it must compile to run, right? So there is no way for this to run if it's a nice piece of JavaScript until you hit that line and you're just like, an error. Awesome. After 30 seconds of running, we have an error. It doesn't happen here, which is a good part of Go. So really, when you look at this, it's not really easy to read, but at the same time, it's very easy to correct. It's very easy to audit. It's very easy to test. And this is what we want to do. So now if we look into the whole framework and how it works, there are three main parts to this. The first one is searching. And so for every block that I've shown you, now to be exact, this is not the thing that gets embedded. The only thing that gets embedded is this thing. So you want to take basically the whole function, the whole block, and all its parameters, and create embedding for it, so that for every block that you execute in your database, in your SDK, whatever that is, all its inputs its outputs, and the declaration is embedded. If you do this for every single block, then you take a user query, you embed it as well, and you run a similarity search, right? So in cases where you do this correctly, you can have hundreds of these blocks, and you should still be able to quite easily get the right blocks if people ask in the right ways. If people don't ask in the right ways, then you just need to add an example into the function, right? So if somebody says, instead of how many customers do we have, they says how many visitors do we have, right? And you don't find the function block, or you find something totally different, you just go to the block and you add a comment saying, by the way, some users might say customers are visitors, right? Now it gets embedded, it gets that semantic instruction into it, so there is a much higher chance of finding it next time. Again, nothing that you need to do in prompt, you do it on the embedding level. And so we match the functions, and one of the things that we need to do here when we query, when we search, we need to check whether that block actually has what we need. So if we want to count how many visitors do we have, yeah, we can have query visitors or query customers as a function, but we still don't know whether the aggregation, filters, and everything else match the query of the user. And so what we do is we again call LLM, and we just ask it. And this time, again, pattern matching, something that LLMs are really good at. So they pattern match whether the question of the user can be pattern matched into the function block that we actually found, and it says yes or no. Now, if it says no, so we can't really find anything in our library that would execute this, we go into research agent. And the research agent is it's actually the only robust agent, so it is Gemini 3.1 Pro in this case. You can use Sonnet, you can use Opus for this, you can use GPT with high mode on this, but it needs to be something that actually can understand code, and it needs to be something that can write a nice code, nice as you saw, right? And you basically let it edit or create new blocks, and then you approve manually. So you have this library, it goes and it says, oh, I don't know how to count visitors, or I don't know how to count customers. So I will just add that aggregation, or I will add that whole block into my library, and then pass it to the next stage. So you approve it. This can be a pull request. This can be whatever you want, whatever approval system you actually have. We normally use pull requests for this demo. I have just a UI, but really this can be anything. Just create a branch, let the agent do it, push to the branch. That's it, right? And what happens in the demo is that what you can see here is, oh, there's a cursor there. Is it a screenshot cursor? That's nice. All right, so here on this part, what you can see is we didn't find what we wanted to find, right? So we were just like, all right, well, we can't really answer this question, so I'm just gonna hand off to the research. The research agent went and proposed what should be the implementation, and then waited for me to go and approve it. And once I approved, it went and searched again, and then it executed. So you can actually see the whole kind of thinking of the agent with all the steps that we have here. Broker, as you can see, is flashlight model, which again, like just for pattern matching, it doesn't need to be anything else, especially if the only prompt that it has is if the user is asking for something, we don't have just tell them a joke instead. So they are really good at this. At least somebody laughed, okay. All right, and the last part is compose. So what a compose does is it gets the outputs from the search and from the research, potentially, if we have research, and it creates a main Go. So it's very easy. Again, you don't need to do tool calls, you don't need to do all of these things. What you do is you just let it write code and all the FMT print lines there. So it's not really creating an answer in the LLM itself, it's just creating everything in the code. What's really good at this is that one of the things is you can create conditionals. So even if it doesn't know what will be the answer from the database beforehand, it can just create, if there are 0 customers, just print, we don't have any customers in the database, instead of printing a full table where it's 0, right? So all of these things you can just prompt out in the prompt or in the composer prompt. But again, it's very easy because they just use the library and they just use whatever you have there. And again, if something goes wrong, you can just save these, right? So if somebody asks for anything in a Slack channel or in GitHub or whatever, you can just cache these files somewhere on a bucket. And once they're like, oh, this gave me wrong answer, you just pull it and you see what went wrong in the whole main Go that it created. So whatever people do here, the best thing or the worst thing about LLMs is that they're incredibly hard to test. And the best thing about this approach is that now you have something that you can incredibly easily test. Just because there is not really much wrong that can be done here without you noticing first. Alrighty, and now the demo. How much time do we have? Awesome. So I will leave it to scan afterwards if you guys want to. But yeah, this is the, give me a second. Ooh. Alrighty, so this is let me create a new question so you can see it. I will just use this one. It's pretty fast, just because of the fast models there. I disabled all the thinking, because LLMs can't think anyway, can they? No, I disabled all the thinking because it wasn't producing any better answers at this point. But these are all the things that you will probably want to do at scale. So for example, at scale, you will want to have some thinking budget. You will want to maybe use different better models, not just Flash Lite, but Flash or Pro for Gemini, or Haiku maybe for Anthropic at the start, but then go to Sonnet and so on and so forth. It's all about where do you see the scale, right? What works for you, what doesn't. So start with the small models, then try the bigger and bigger ones until you find whatever works for you. So what you can see here, it currently went into the broker, says, hey, checking conversation context. Then it created the embedding, and then it scanned for some building blocks, and it found some. And again, went to the LLM and decided that there is actually a block that it can use. So it wrote a main.go and ran it, and gave us a nice table. And this is what happens when everything goes right, and when you don't get resource exhausted on the APIs. We can also look into the main.go here. Give me a second, where is it? Yeah, so what a beautiful code it made. If anybody wants to read it, no, I don't think so. So let's go back to the demo. So one of the things that we do here and that I forgot about was we let it write main.go, but not all of it. So there's this part of go run/go build where it downloads automatically the dependencies, which we don't want to do. We want to give it just our dependencies at the start and just not use anything else. So what we do is we actually scaffold the main with the imports and with a bunch of things at the start, and we let it just write the body of the function itself, so that you don't need to care whether it imports other stuff and stuff like this. But then, what happens if we give it another question? I have one here. And let's see if this works. So this question is, which day of the week has the highest order volume? And again, you will see basically the same thing that we saw in the previous demo, but this time it shouldn't actually find, or it should decide that there is not such a block, and then we can go and, oh no, it actually found it. Did you find it? It shouldn't be there. Let's see what he does. I don't believe him. Well, it probably can do that then. Do you guys have any questions that it shouldn't have? All right, let's do something different. So I'm pretty sure I didn't let it implement this, so maybe he will come up with something. But the idea here behind this is, I think, pretty easy for the demo. That if you want to scan that QR code, you will then see that it's pretty easily implemented right now. So it really depends on like how much do you want to scale this, for a company or for your use case. And yeah, it now says it didn't find it, so handing off to research, and hopefully research will tell us that it can actually do something here. Any questions while we were waiting? Yeah.
Yeah. So the tools are automatically like added to the database, right? So how do you review it? Like, is there any process of the review for that?
Yeah, I will show you once this is done. But there is definitely this. So what you can do here for the demo is just a simple UI where you will see the diff. For any kind of normal use case that you want to have in your company, it should be Git. So it should be, the repository should be directly in GitHub, GitLab, wherever you have it. Let the agent use a work tree, let it push into the work tree, and then create a pull request, merge request, whatever you want. So this is the way we review it in the real world, where we create the pull requests, and they must be merged back into the library.
So how do you immediately answer to the user, like in this state of the process where the tool doesn't exist yet?
So for this demo, it doesn't, it just waits.
Yeah.
For in the real world, what it does is you have that work tree. So it can actually go to the user back, and it can tell them the result because it has it in the library. The only caveat that we always add there is like, this shouldn't be a trustable, like a trustable answer yet. So it can be like, it can return, like how many customers do we have? Oh, return back the block that we created with the customers executed, and then also add to the end of the answer, this was produced by something that is not yet approved.
Yeah.
So
do you somehow evaluate the amount of the risk of the created tool like for you? Because I can imagine you are using like a huge customer database, and some generated queries can break it down actually. So if there's some evaluation of the created tools.
Depends on how big your database is on this. Yeah. I would definitely go, the bigger the database, of course, or the bigger the stakes for you, the more it will take time for you to review these things, definitely.
Okay.
Oh, waiting for human, that's me. So what you can see here now is this is the whole query that we have, and it actually gave us like add customer by week to customer dimension. So it adds something here, and it says there's customer by week. I'm not gonna wait. Where's the approve button? Here it is. So I'll just approve it, and hopefully this works. So it's approved. Now what it's gonna do is, because we added a new thing, it needs to embed that block again. So it creates a re-embedding basically for the existing block, and now it goes again. So it goes into search. Now it's gonna decide if what we wrote is enough, which is funny. Awesome, so it looks like it found everything. And now again, it's just gonna write the main Go, and we can inspect the main Go if we want to, but it's a generated code, so. The idea, of course, behind this is that you're probably not gonna have a UI like this. You will probably wanna use Slack, Discord, whatever you want here for the customers or for your internal team, whatever, can access it. For this thing, it's really just a demo environment. But in the real world, we normally use Slack, we normally use Discord to have these. It's just really nice to have all this reasoning there with all the details. Also, for the real world, these agents are not as fast as these ones, right? So the dataset here, along with the agents, because their context is so small, they don't have many tools. Well, these actually don't have any tools. Awesome. So it wrote something that doesn't really work, but it wrote it. I think this was we probably don't have actually the data about weeks in the database this way. This is something that, of course, needs to be done in the research agent, but at least you can see how it works, even if it didn't work in the end. So again, I will go into the presentation, and I will share this slide once it's ready, or at the end. And so this is how it works in the end. So you have a user asks a broker. If a broker deems that this query is not for the agent and it's something that is maybe off topic or that should be a security risk, whatever, it goes back into the user. If it says that it is actually a good query, it goes into search, embeds that, and now it decides whether we have everything in our library or if we don't. And if we don't have everything in our library, we go and we build it, we approve it, and then you go into composition again. Write main go, and you can just execute. So this whole loop, would it be probably far better if I actually reviewed the code that he wrote, and so it wouldn't broke. But in the end, yes, in the real world, you would probably run that code. You would probably actually review it, check your data and stuff like that. And then once another person asks that query or similar query, now you have that building block that you can actually trust. And that's it from me. So again, I'm Peter. I'm from Navigara. If you want to check out what we do, you can go to navigara.com. And that's it. Thank you so much, guys.